Hello from Cleveland. Today we're going to go over a CSWA problem. This is a Revolve feature mainly. And we're going to just first take a quick look at the requirements. So what we're going to do is come up top. See, this is an advanced part, a tooling cylinder. It is in millimeters, so we're going to use ISO. 2 decimal places, not too important as long as you have at least two. And part origin not important. That makes it a little easier on us, and it gives us some material. So what I like to do here, I look, what is the base of this part? I told you it's a revolve. We can see it's a 3/4 revolve around here, but I see the sketch for the initial revolve is down here. So we're going to take a look and we're going to get started. I'm going to open SolidWorks. And then I'm going to come down over here, File, New. We are making a part. And the setup, make sure we're in millimeters. I'm going to open Document Settings. And we're going to come down to Document Properties, Units. See, we're in inches. We're going to change that to millimeters. And you can use ANSI or ISO. Usually use ISO with millimeters, but I'm going to leave it in whatever we're at. So we have a sketch we're going to start, and that sketch is going to be this. So I'm going to take the correct plane, go sketch, we've got this, and I want to sketch on the right plane. I'm going to start with the center line, arbitrary length, and this might be a little overkill, but I like to still constrain my centers to my centers. And I can do that there with the coincident. That also can be pulled up on the menu that was on the left over here that's now gone. So, starting our part, let's take a quick look at this and we'll make a fast sketch. What we have is an up. I'm going to do the fillets last. So I'm just going to come up, right angle, up, over, right angle. These are dimensions, so I'm going to draw in this chamfer instead of doing it last because I see the C dimension goes to the edge of the chamfer. So we're going to draw this V in here, over again, down, back, over. And we can see that B is the same on both sides, C is the same on both sides, and A will give us our overall length. So what I'm going to do, I'm going to draw A first. Let's see, what do we have for A? 146 millimeters. So I come in here, I'm going to draw a quick line. Just make sure that it is parallel to the line below. I'm actually going to just go ahead, dimension 146, enter, and then we'll do the same. I'll do it the opposite way this time. You click that, I got the line. You need just the center point and the origin. And then you can see I'm kind of covering. We're going to make those coincident. Now that is fully constrained. Next, we're going to do our ups and overs. So we come up, over, up, over. Here's that V cutout. You want to get a 45 if you can. If not, we'll dimension it later. Over and then downward. And if you notice, I'm trying to line these up with each other. That can be fixed in post, but better if you can get it. And now we have a solid profile. You can tell you have a solid profile when this fills in a color. If that was not closed, it would still be the same color as the background. So before I even start dimensioning this, I'm going to remember that first this, I think was B is equal to B. So I like to use, when you hold control and let go of control, let's do that again. Now holding down control, and when I release, I should have got a collinear, but I didn't. So I'll do it over there, collinear. I'm gonna hold, release, there it is, and collinear. We'll have to go back a couple lessons if you didn't get collinears before, but that's okay. So now what I need to know, the heights of these, and the distance between here and here. We know these are 45, so before we leave the screen, we'll just go ahead. 45.00, very good, that came in nice. And, oh, I don't want to do that, that's going to over dimension because of my constraints. So it saves us a mistake there of over dimensioning. And the other thing I did, I made these collinear, but I need to also make them equal. So this will be equal here, the one that through the pop-up, and C equal to C through the pop-up. Now, let's get our sketch back up here. We're gonna come in here, B, C, B, and C. Let's see what B and C are. B is 20, C is 30. So we'll go ahead and go back and put that in. And 20 millimeters. Then C, a little long, it's going to be 30 millimeters. Now there's one, what I do, I like to go through one sketch at a time and make sure I have all the dimensions. So I don't have R2, but I do have B, C, B, C, A. Now I need this 2.5. I've got both 45s. So we'll add our 2.5 really quick. 2.5 millimeters. Now we need the heights. This is not on the sketch we had, but we have now consumed everything between the R2 radiuses on this sketch. So we've got to come somewhere else. This looks like it's going to be last. So we're going to take a look at this sketch now, and it doubles up the R2. But importantly, we have diameter of 50 and diameter of 80. So we're going to add those in. That should button up the sketch. And instead of it giving you a radius if you went to the solid line or hold above, if you come below, you can have this to give you a diameter. And like we said, we're going to be at 50. And then this up here of the center line will be 80. And there we go. We're ready to revolve now, which is the key of this whole, I guess I'll call it the heart of this operation. And so what we're going to do, going to come to features, revolve base. There it is, creates it right for us, but as we noticed, ours is only 270 degrees. This is 360, so we're going to change that to 270. But weird, it's on the wrong side, right? No problem. If you click this next to the blind, we can flip it so it's the same orientation. You'll get the same weight either way, but just nice to match what you've got. So we'll let that roll. Now real quick, we're going to add our fillets. Fillet command. Set at 10 millimeters. We wanted 2. Those were our 2. And then we're going to come grab that and come over to the other side and grab that. Now we've got our fillets. Now I always like coming back to the original view. So now, like I said, what I like to do is check off, do I have everything done on the sketch? Yes, the 80, yes, the 50, yes, R2. Now we know we have this sketch done because R2 was the only thing missing, so our final feature will be a cut on the end. And we'll come back here. So we're going to start a sketch, new sketch, come here. And I'm going to draw a slot that goes beyond the part so I have less to draw. So I'm going to pick any old slot. I'm not sure which I'm on, but as long as that is the correct, this is parallel to the axis there, we're going to be good. So we've got our slot. Let's see. Diameter is 6. Bottom edge 7 from the top and 12 over. So let's go one by one. We'll first do the diameter. And if you click here, it's going to give a radius. So I'm going to take these two to get a diameter of 6. And now we remember that it was 12. The center of this hole to the edge is going to be 12. 12 millimeters. There we go. Now, I believe it was 7 from, yeah, 7 from the bottom of the part to the bottom edge of the slot. And now this dimension, just to make it fully constrained, whatever it is, doesn't matter. What we're going to do now is do an extruded cut. Features, extruded cut. And I've already got it set up that it's going through all, so that's nice. You might have been on blind and it's giving you a dimension through, but we want it all the way through the part as was specified on the paper. So we've got that. Now, without looking back, I remember this was 1020 steel. So you'll put that in your material here, right click, edit material. And AISI 1020 steel will apply. Close, and let's see what we get. If we get a result that is on the sheet, we're going to go to evaluate. mass properties, and it is 3367.57 grams. And there we go, exactly 3367.57 grams. We have completed this part and we're on our way to passing the CSWA. Hope this helped you. If it did, please respond in the comments. Shout me out. Thanks. Have a good day.